Hello, Atish. Hello, Atish. So we will start in 5 minutes. So we will wait for 5 minutes for others to join. Okay. At 6:05 I will start. Yeah. I think we can start off. Yeah. So rest of the students can join later also. Yeah. So welcome all. So this is week 13 live interaction session for the Aspen Plus Simulation Software course. It's a basic course for the beginner, and I have been TA for this course where in past 12 weeks we had tried various simulation in Aspen Plus to get ourselves familiarized with the software. Okay, so where we started with a basic modules which are available in the Aspen Plus, and then after that we moved towards various process plant simulation in the Aspen Plus. Just brief bio about me. I know you all guys all know by now that I'm currently doing PhD at IIT Bombay, and I had completed my bachelorate from MS University, where I was introduced to this course. These are the channels via which you can contact me. I mean, students had contacted me on LinkedIn and via mail for various queries. So in the Aspen Plus, so far what we have done is, oh sorry, I keep forgetting. Yeah. So in the Aspen Plus software, so far what we have done is that, as I was saying, we started off with the, let it load. In the initial week, we started off with the various property estimation methods in the Aspen Plus, how to do property analysis, whether it be pure component analysis, binary component, ternary component, what are the basic process plant models available, be it heat exchanger, be it the column, separator, mixers. We try to simulate all of them. Then after that, from week 7 onwards, we move forward with the various case studies where we try to solve a particular example in the Aspen Plus. It was kind of a process plant unit or a small unit of a plant, did very optimization, sensitivity analysis, and so on. So this is the last lecture for this series, and in the today's class what I have planned is we will start off with two simulations. We will do example problems in the Aspen Plus, and afterwards we will move towards the quiz part, and I will give you a brief overview at the end what we have learned so far. So before starting, do you have any query that you want to specifically know? So this is the last lecture, then you can discuss it out. I know others are not there. Athish, you are here. So if you have any doubt, you can ask it out. Afterwards, I mean, you have exams, so best of luck for your exams. But if if you have any query, it will be nice to sort it out here only. Okay. So I assume you don't have any query. Uh, in that case, we will start with the few example problems. So I have taken out two example problems today. So first we will do that, and then we will move with the quiz part. So I have designed various questions for today's class. So last time some student was asking me to do this kind of a problems. So that's why I have taken it out. So in the today's class, I will upload this PDF also separately for the question. I didn't had a time to put it in a presentation. So we will start with the first this question, second question, which is a red flag column problem. Okay. So the problem statement is given as that we have a distillation column, red flag, used for fractionating a ternary mixture which is of HI2 and water. Okay, so this is how the flow sheet looks like. Feed data is given, that temperature, pressure, condition, flow rates, composition, and at what stage this feed is coming into the red flag column. Now the column operates at 4 bar pressure and it has total 5 trays including partial condenser and reboiler. In the simulation, the reflux ratio to and distill to feed ratios are taken as 0.94 and 0.6121. So the column data is also given. So we have to simulate this process with the help of NRTL thermodynamic package. Then what has been asked, considering sieve tray type with a tray packing of tray spacing of 0.6096 meter, report the Aspen Plus generated column diameter. Calculate the column diameter considering F factor equal to 1. Okay, and compare the calculated column diameter with the value obtained using this given equation. Okay, so it's a correlation that has been given to compute the diameter of a column, where TC is the diameter, the T is average temperature, P is the column pressure, V is volumetric flow rate, and MWA, this part, is the average molecular weight, and the gas constant is also provided. Okay, so we'll start off with the simulation. Let's open the Aspen Plus software and add all three components. So we have three components, HI, I2 and water. the method that has been asked us is NRTL. So select NRTL. Okay, you have to wait for a few minutes. Okay, go next. Run the property analysis. Only one person. Yeah. Okay, so property analysis is complete. Your result may not be available. Oh, this is fine. Okay, now let's go to the simulation. So our process flow sheet contains only distillation column, red flag column part, where feed is coming and it's separating into distillate and bottom. Okay, so in the column, select red flag, add it. Material stream, we have feed, and both see in the distillate part it's vapor, so you can see it's connected to top part, and the bottom it obviously is a liquid. So distillate is here, this is our bottom. Let's rename them. So this is our feed, distillate, bottom, and this will be red flag column. Okay, now let's enter the details. So what information we have for the feed? So for feed, we know the temperature, pressure, flow rates and composition. So let's import it. Temperature is 150 degrees centigrade. Pressure value is 4 bar absolute. Flow rate is 0.2 LPM, liter per minute. Okay, that's a different volumetric flow rate is given. 4. So we have been provided with the LPM, which is this much liter per minute, so 0.2 volumetric flow rate, and the composition. So composition is H2 is 0.51, HI is 0.1 and I2 is 0.39. Okay, now here it's not specified like what this composition is it molar or mass, but so I will consider it as a mole fraction. And let's select mole fractions. Water is 51%, HI is 0.1 and I2 is 0.39. HI is 0.1, I2 is 0.39. Okay, go next. Now the specification for red flag column. For red flag column we have been provided that it has total 5 stages including condenser, partial condenser and V-boiler. So total stages are 5. Okay, condenser type partial. So here we will select partial vapor because as per provided in the flow sheet, we only see the vapor product coming out of the distillate, out of the condenser. Okay, so I am selecting partial vapor condenser. Then what information we have? Reflux ratio is given as 0.94 and distillate to feed ratio is given as 0.6121. So reflux ratio 0.94 and distillate distillate to feed ratio 0.6121. 6121. Then it's still showing incomplete input. Okay, yeah, this is complete. We have to add where feed is entering. So feed is entering at above stage 3. So select that. Feed is entering above stage 3. Pressure value for the columns. So for that pressure, column is operating at 4 bar absolute pressure. That's it, and no pressure drop data is provided. So we will select 4 bar stage 1 pressure, which is a condenser pressure, 4 bar absolute value. Okay, go next. I think all the inputs are complete, so now we can run the simulation. After that, what has been asked? First, we have to simulate using NRTM model. Then, okay, so once we will do without providing any internal specification, then we have to consider CU tray type with a tray spacing of 0.6096 and then report the column generated diameter. Okay. It will take few minutes. Has anyone else joined? Okay, yeah, Harshit. It's completed. Let's look at the column results. So we will see the stream results. At bottom, which is in liquid phase, top is in vapor phase. So how much separation is achieved? So we had given the let's look at the molar fractions. Let me change its unit to per minute kind of. So iodine is a major part of our bottom components, where you can see HI, both HI and H2 are in very few amount, while the top distillate contains mainly HI and water. Okay, so this way, through this column we had achieved separation of I2 iodine from HI and H2. Okay, and so in this problem no further separation of HI and H2O is asked, but then after that you can have also another column to separate at HI and water. Okay, so here you can see almost from 2.253 to 2.226, almost separation, 100% separation of I2 has happened. Similarly for HI and H2O also, all complete separation has happened. If you will see these stream results, let's look at the balance. I want to see duties. So first we have condenser. Condenser duty is 0.036 minus 0.036 kilowatt, while reboiler duty is 0.064, so double the amount of condenser duty. Okay, now this was without providing any trace specification. Now let's look at into the column internals. Okay, we have been asked to consider a sieve tray type with a tray spacing of 0.6096 meter and report Aspen plus generated column diameter. Currently in our red flag column, if you will see the results, okay, so we get this summary where condenser and reboiler data is given. We have balance, we have split fractions, okay, but we don't get the column diameter. For that we have to do some column internal calculations. Okay, so for that we will go to column internals. Click on new. I hope I have complete package. Has anyone joined? Do any of you guys have access to Aspen Plus? Either Harshit or Atish? And is it possible to share your screen? Else it will take some time to run simulation in my laptop. So you have to wait.
Yes, sir, we do. I don't have.
You don't have access?
Yes.
Okay.
Yes, sir.
Okay, then fine. Atish, what about you? Nikhil has joined. Nikhil, you generally use your mobile, right? So you don't have Aspen Plus access right now.
Also don't have it now.
Okay, then we might have to wait. Okay. Yeah. So we have created. Okay, it's running column internals. In the internal part, so we have been asked to use sieve type tray with a tray spacing of 0.6096. Okay, so model that we will be using will be interactive sizing, tray column, sieve trays. Okay, number of passes, this thing we won't change. Now coming to the trace spacing, so trace spacing here is 0.6096, that is exactly same as what has been provided to us. Okay, so we don't have to change it. And then tray diameter. Okay, so for that, in order to get in diameter, I think we have to change from interactive sizing to rating, and it should include static calculate pressure drop. What is remaining? Internal is not complete. Starting stage, ending stage, and internal must be specified. Oh, yeah, starting stage. So we have total 5 stages. Okay. Oh, sorry. Since stage 1 is our condenser, so from 2 to 4 we will have a tray spacing. Okay. This two data is complete. What else is remaining? Internal not completed. Diameter must be specified when mode is rating. Yeah. So we have provided from 2 to 4. So column is total of 5 number of theoretical stage, including condenser and reboiler. So condenser is stage number 1, reboiler is stage number 5. 2 to 4 is a sieve tray. Okay, with a default tray spacing that we have, that has been changed. And since we have used interactive sizing, it has computed diameter accordingly. Now we will run the simulation and see how does it affects our result. So results are available. Go to the stream results. Let's look at the molar flow rate. So we have been looking at kilomole per mole per hour. Right. So almost same sort of a specification we have got, with more amount of HI present in the distillate. Okay, so it's essentially almost same since we have not changed much of the internal part. Now what has been asked to us? Consider the sieve tray type with a tray spacing, report the Aspen plus generated column diameter. So for our internals, column diameter generated by Aspen plus is 0.01095 meter. Okay, if you will see hydraulic plots also, why hydraulic plots are not generated? We should have a plot here. I'm not sure why it hasn't created hydraulic plots. Anyway, so that was the second thing that had been asked. Now we have to calculate the column diameter considering F factor equal 1 in English engineering unit. Okay, now this is something new that we have to understand. Okay, in this selection, so now where is the F factor? Just a minute, I forgot this parameter. So we have to vary this input. Accordingly it will calculate the new diameter. Okay, so let's search for the F factor first. Okay. Uh, Now we want to understand the F factor part, right? It is related to reduction factor for tank insulation, piping geometry. No. Fire safety. Yeah. Using same method, when simple tray packing hydraulic option is, you can contribute that the flooding approach be computed. Yeah, so this F factor, it's a flooding factor that we have to change. It should be system foaming factor, aeration factor, overall design factor. This is already one though. Tray geometry. Yeah, so I think this is the flooding factor here, the system foaming factor or flooding factor. Why it's not showing? I just have to check the whether this is the part that we are looking for, or it's something else. So let's keep this point F factor aside for now. Okay. I will check and update you on the same, what exactly we have to change. I hadn't looked it earlier, but I will let you know. Okay. So if we will change the F factor, the the column internal will change to some extent, and we will get a different diameter. Then next, what has been asked to us, compare the calculated column diameter with the value obtained using following correlation. And the correlation is that we have vapor flow rate in pound mole per hour divided by 900 pi into average molecular weight into temperature is to 0.5 divided by the pressure value. Okay. So let's see, if we calculate this, do we have all the data? So here what we need is volumetric flow rate. So volumetric flow rate, we know this flow rate we need in, sorry, vapor flow rate we need in pound mole per hour. So molar flow, you change it to pound mole per hour. Okay, so this is the distillate part, that is a vapor flow rate, which is 0.00797. Column diameter in feet, this we will get. Average column temperature in degree Rankine. So here in the balance part or from the profiles, you can see you get the column temperature. So we want temperature in degree Fahrenheit. So we have 5 stages. Do average of this 5. Calculate the average temperature. Gas constant is given in the English unit, psi feet cube in pound mole per. Okay. Pressure value. So pressure value also we have to take an column pressure. So that we already know. This we have specified, which is 4 bar absolute. Okay. But here you have to put it in psi. So be careful about that. And then vapor flow rate, the distillate flow rate, you will put it in average molecular weight. So we know all 3 components. So for all of them, in our stream results, molar densities, average molecular weight is given. Okay, so this will be your average molecular weight. Put all this value and calculate what is the DC and whether it's matching with the column diameter that we have obtained using the Aspen Plus calculation or not. It should match, since all the correlations that Aspen Plus is using is based on some heuristic approach. So based on our column spacing and the other data, Aspen Plus has calculated the diametric value, and this we have to check with the correlation, and you will find when you will calculate it that results are almost similar. So this was the first question. The F factor part I have to verify it because I hadn't shown it earlier. So I will just confirm it, and what I will do if I find it, then I will update it in this presentation which is uploaded on the drive. Okay. So now moving on to the second question, which is again on the separation.
Can I answer?
Yes. Yes, Nikhil, go. You want to ask something?
शेयर कर सकते हैं?
Yeah. Go ahead. Yes. Nikhil? You wanted to ask something? I think you are on mute, so can you unmute yourself first? Hello.
Yes, sir. ये question. Consider composition of
Decomposition of hydrogen peroxide into water and oxygen. Your kinetics data is given. Reaction order is 1 with respect to H2O2. The gas constant is given. Choose specific chemicals with matrix unit template to create process flow sheet. Choose O2 as Henry's component. Estimate the binary interaction parameter. Yeah, so what happened in this question?
सर एरर दिखा रहा है कुछ प्रॉब्लम.
What error?
प्रॉपर्टी इश्यूज आ रहे हैं पर आप ट्राई सॉल्यूशन.
Okay. You can stop sharing, I will. So this is this week's course, right? I mean,
हो सर.
week 12, right?
वीक 12 का प्रीवियस असाइनमेंट मैंने
Last year का.
मतलब last year.
Okay, let me check. You can stop sharing. This is the assignment, right? Okay.
Yes, sir.
Okay, so let's read the sentence. So this kinetics data is given. We have to use unifact method. Analyze how the concentration of H2O2 will drop with time if the bottle is kept at room temperature and atmospheric pressure. To simulate the bottle, use a batch reactor with one feed stream, one product stream, where the reaction is taking place. The feed stream has 97 kg per hour H2O, 3 kg per hour H2O2, and 1 atmosphere 25 degrees centigrade. The stop criteria reaction is when H2O2 conversion has reached the value of 0.9. The batch feed time for H2O2 is 1 second. The maximum calculation time is 1 month, and time interval bit profile point is 1 day. Okay, so you are getting error at exactly where, in the property analysis or simulation itself?
सर प्रॉपर्टी एनालिसिस नहीं हो रहा, उसके बाद सिमुलेशन तो ऑब्वियसली होगा.
Okay, let's check it out. I have to wait for a few minutes. Okay, so what are all the components we have? We have water, oxygen, and hydrogen peroxide. So we have to use choose specialty chemicals with matrix unit template to create a process flow sheet. This is fine. Choose O2 as the Henry's component. Estimate the binary interaction parameter NRTL1 using Unifac. Okay. So we have to use NRTL method. Go next. NRTL method. Okay. And estimate parameter using Unifac. I don't understand what they mean by choose oxygen as Henry's component. This I have to see. We have this option of Henry components. So let's see. Yeah, results are generated. Warning in physical property. Property name renown for component pair H2 H2O2 cannot be estimated using Unifac because of the missing input parameter. Okay. Yeah, these are some normal warning that might be related to some uh, computational error. But see, property analysis is working, Nikhil. They had provided.
सिमुलेशन में सर दिखाए मतलब सिमुलेशन एक्स सर्कुलेट नहीं होगा
Why?
ट्राई किया
But you said property analysis में ही issue आ रहा था ना आपको.
इसके बाद से मैंने सिमुलेशन किया फिर रिजल्ट ही शो नहीं हुए
Results are not showing up. Okay, let's see.
बोला कि इनपुट प्रॉपर्टी एनालिसिस ऐसे दिखा
Okay, let's see. Choose oxygen as Henry's component. We have one Henry compound. So let's see if I can add oxygen as Henry component. Yeah. Okay. Let's rerun the property analysis and see what happens. So now we are only considering oxygen as a Henry component. So it won't compute the binary parameters between H2O2 and H2O. Yeah, so results are available, and if you will see, okay, so this is working. Now let's go to the simulation. So we have to use batch reactor. So for that we will use R batch. Feed condition. So feed condition is provided as 25 degrees centigrade and atmosphere pressure. (97 kg per hour water and 3 kg per hour H2O2). So 25 1 atmosphere, mass flow rate 97 0 3. Go next. Okay, so temperature specification, again same room temperature reaction is happening, so temperature will be constant temperature of 25 degrees centigrade. Kinetics, we have to add the reaction, so create a new reaction. Let's say power law. Go to reaction R1. H2O2 1 mole, exponent is 1, is forming H2O and O2, and our psychometry is okay 2 they are taking it as that way, so let's do it 2 2 and 1. Okay, correct. Then kinetic data is given. So here exponent is 0 for the products, since it's first order reaction with respect to H2O2. You can provide it as 0 or let it be that way. In the kinetics, K0 value is given as 4.8 10 to the power 8. 4.8 e to the power 8. Okay. Energy value is given as 78684. Sorry. 78684. Now unit. So here see R, the unit for R rate constants are given, right? Kilojoule per kilomole Kelvin. So E unit will be in a way kilojoule per kilomole. You can select it that kilojoule per kilomole. T0 is not provided, so that is fine. Now let's go to the again batch reactor part. Here we have to give a stop criteria. Stop criteria to stop the reaction is when H2O2 conversion has reached the value of 0.9. Okay, so let's say this is our first criteria. Reactor variable, so we will put let's say conversion, stop value is 0.9, component H2O2. Okay, approach from below. So these are the data that has been given in our problem statement itself. See the batch feed, the stop criteria is when H2O2 conversion has reached a value of 0.9, approach from below. The batch feed time for H2O2 is 1 second and maximum calculation time is 1 month. So operation time, batch feed time is 1 second, maximum calculate time is 1 month. Okay. And time interval between profile is 1 day. So let's put it as 1 day. Okay. All the data are complete. Now let's run the simulation. What questions has been asked to this question here? The operation time of the reactor, the heat load per cycle of the reactor. Do the simulation once again, but with a cooler between the feed stream and the reactor. The feed is cooled to 5 degree with no pressure drop, and the cooled feed is now fed to reactor operating also at 5 degrees centigrade. Also the following question with accuracy of 3 degrees. Okay. Let it run. We can wait. Yeah. So results are available. See, I'm not getting any error here, Nikhil. There are no errors. What kind of error you are getting?
Then I will show you.
Okay, go ahead.
Sir, wait करो. Simulate कर रहा हूँ.
Okay. So till then let's verify our answer. So it has been asked the operation time of the reactor in hour. So go to the profiles or the results here. So operation time. So the range is given between 39 to 41, and our answer is 40.7. So which is matching. The heat load per cycle of the reactor is how much joule? So heat load per cycle in joule. So 2090.54 negative value. So that is also correct, minus 2090, which is in between the range. Then next it has been asked to use a cooler in between the feed, where cooler cools down the feed to 5 degrees centigrade with no pressure drop, and then reactor is also operating at 5 degrees centigrade. So let's change that also. Let me add one exchanger unit. Okay, now let's add the specification for this cooler. So block B2, temperature 5 degrees centigrade, no pressure drop. Okay, for the reactor also, now reactor is operating at 5 degrees centigrade, so we have to change that also. Instead of 25, let's select is at 5. Next, and run the simulation. So results are available. Let's verify the answers. The heat duty of cooler. So for cooler, go to the B2 block, result, and you will see the heat duty. Heat duty is asked in which unit? Kilowatt. It's given between minus 2.26 to 2.22. So minus 2.24, which is correct. The operation time of a reactor, now it has increased to instead of 40, it has gone down to 390. So let's see what has happened in our case. So operation hour is 397. Okay, which is again in between the range. The reactor accumulated a mass of this much gram of H2O after 120 hours. So for that, let's look into the profiles. We have to look at the reactor accumulated mass of this much gram of water at 120 hours, after 120 hours. So here we have temperature, set point, vapor flow, cumulative, total mass. What else we can add? Composition. Yeah. .98 after 120 hours. Net rate, driving force. We have to see the accumulation, right? Accumulation should come vent accumulator. No, there is no vent.
कर सकते हैं स्क्रीन ये दिखा रहा है सर
Yeah, just a minute. You can share your screen.
सर ये बॉर्डिंग चाहिए नहीं
Your screen is not shared.
Did you share क्यों
Nikhil, I cannot see your screen.
शेयर तो कर शेयर तो दबा
Okay, now maybe he's busy with some other stuff. Okay, so first we want to see the accumulation part. I mean, it should be somewhere in the profile section only. So the question says the reactor accumulated mass of this much gram of water after 120 hours. So just a minute. Yeah, what's the information? No, see, these are not the errors. As in, see, when these are kind of some notes. Okay. Error when you will get this yellow marking, that result available with the warning, where yeah, or result available with the red marking. Okay. In that case, you have to worry about it. These are some notes that it is giving, that okay, you have used this property estimation method, but there are some limitations or some shortcoming, and it is specifying. So see, warning in physical property system, prop name, renown for component pair H2O2 and O2 cannot be estimated using the unified method as specified because of missing input parameter. So it's kind of a giving you the warning, but it's not a, it's kind of a note. If it's coming with that yellow thing, that result available with the warning, then you have to think about it, whether then it might be a correct error. Okay, this is not the error, you are mistaking it. And if you have a doubt, you can search about this error on the Google or some other forum, and you will get the idea what exactly this means. Okay, so try to do that also. Yeah. Coming back to again your problem. uh, just I was looking for this accumulation of mass. Do you know where the accumulation is provided here? Oh yeah, reactor accumulated mass, and we want it in gram. So yeah, under composition section we have to select the reactor accumulated mass, and the water accumulated at 120 R is 27.16 gram. So our value is coming in the range. Okay, so this simulation is working. So right, I hope it clears your doubt. See, some of the errors you have to understand that they are not actually an error but kind of a note. And when you will get an error when results are available with the warnings or the yellow marking and red marking, so it's kind of indicates the level of warning that you have to worry about. If results are available, uh, with what kind of warning you are getting, it's something, it might be related to uh, kind of a note thing, that okay, keep this thing in mind. While if you get a result available with the error with yellow marking, that means there are some issues. Result available with the red marking, that means your simulation is not working correctly. So then you have to worry about it. Okay, I hope it clears out. Now let's move on with the new example. So next problem that I had selected was yes. So next problem is again on the separation process part, that we have a ternary mixture of propane, propylene and pentane. Okay, with a flow rate has been provided, and feed is at 100 degrees centigrade. And oh, this has been cutted out. I will check this value. Okay, then so you can see the feed is pumped into our stripper has no condenser, it's like it's a, and all the vapors are going into the secondary distillation column, where the bottom product of your column is again recycled back to the first column. So you have stripper, you have rectifier. Okay, now the data for the stripper and rectifier is given, that stripper has total 100 stages including condenser reboiler with a reboiler duty. The stream F enters, the stage locations are given. R1 enters above the first stage, the top stage pressure is given. Each stage pressure drop. The pump P2 has increased 20 psi pressure. Okay, so pump specification, all these specifications are given. And then we have to use RK-SOV method, thermodynamic model, simulate the above propylene propane mixture separator plant and report the product composition. Perform the sensitivity analysis to observe the effect of the second column efficiency varying between 20 to 100% on propylene mole fraction. Okay, So pretty straightforward. Let's start a new simulation. Just a minute. Now let me check the missing data also. So this pressure value here should be, this is 4. 290 psi. Okay, the stream is coming at 290 psi. It's taking its time. It's on. Okay, so coming back to our problem statement said we have to do the separation of propylene propane mixture, where we have pentane present as an inert. So let's add our component. So first we have propane. Search for the propane. It's taking its time. Maybe Nikhil, you can share your screen. We can do the simulation in your Aspen Plus.
Yes, sir.
Yes.
So क्या काम?
Can you share your screen so we can do the simulation in your software? It's taking time to run Aspen Plus in my laptop. That's why. Yeah. Yeah, it's visible. So search for propane. Find the component. Click on find. Below component ID, right?
Time needed.
Sorry.
So search करना है.
ओके. ऐसा आपने सिर्फ एक ही स्क्रीन शेयर किया. पूरा स्क्रीन शेयर कीजिए बिकॉज आई कैन नॉट सी दी सर्च मेन्यू.
अच्छा.
Where can we get previous year assignment? Atish, for previous year assignment, is it that I have access to previous year assignments through NPTEL, and Nikhil, he might have enrolled in the previous year part, so that's why he has access to that assignment.
Honestly,
Yes. Nikhil. आप अपना पूरा स्क्रीन लाइक शेयर योर एंटायर स्क्रीन एक बार स्क्रीन शेयरिंग बंद करके बिकॉज आई कैन नॉट सी दी अदर पार्ट. Okay. Again, I think you have added only Aspen Plus. Okay, it's fine. Add propane. Find propane, add it. Find propylene, add it. And third component we have is normal pentane. Atish, I think you haven't been following the previous lectures. So for the exam, you won't be asked to do a simulation. It will be kind of a part A question of your all assignments. Okay. I have told this to students many times. Yeah. Add propane. Now search for propylene. Not propene, propylene. Pylen. No, go down. It will be uh, in the compound name when it starts from P, you will get propylene. Ha. Slightly up. Yeah. Now slightly go up. Go. Up, up. Ha. See, propylene. Yeah. Add it. Add. And then last compound is propane. Sorry, not propane, pentane. Pentane. My mistake. Pentane. Yeah, I'm here. Yeah. Normal pentane. Add it. Okay. Close this. Press next. Now select the RK show method. No, from menu itself you find it. Go up. Huh. It went. Go up. Yeah. Yes, this one. Okay. Do next. Run the property analysis. Yeah. Go next. Now go. Okay, it's still running. Yeah. Okay. Yeah. So the property analysis is done. Go to simulation environment. So let's place all the components. So we have first pump. Okay. Now then we have to add columns. So go to columns. Yeah. In the option of red flag, select the option menu for the red flag. The lower arrow. Not this one. Select the downwards arrow beside the red flag. Ha. This hide this Google Meet part. It's affecting it. Ha. Now select the strip 2 part. So that will be your left, the second row, first column. Ha. This one. Select it. Add it. Say it as C1. Okay, strip. Ha. That is fine. Okay. Now we have to add another pump. Yeah. Now add another pump ahead. Yes. Just say it P2. Yeah. Then we have to add second column, so that is a rectifying column. So go to columns, yeah, in the red flag option select the second row, second column, yeah, rect, and edit. Now uh, we have to connect these streams. So one feed is coming to the pump, from pump outlet is going to the stripper, stripper vapor from the stripper, yeah, that will go to the rectifying column. Rectifying column, call it as D1. That is also okay. Then bottom of rectifying column is going as a feed in the stripping column. Yeah, connect it. So this is fine. The bottom product is just going out for the stripper. So just end the line. Call it as B1. Now the bottom of rectifying column, you add it to the pump input. Yes. Let's call it as B2. Pump output will go to the stripper as an input. So first column, select its input. First column. Where your P out is connected, connect it there. Where your P out is connected in the first column, the stripper column. Yes. Yeah, put it there. Okay, that is fine. Yes. Call it as R1. Done. So our flow sheet is complete. Now we have to add the the last part is remaining, the rectifying column top vapor. So rectifying column has a vapor coming out, only vapor, yeah. So that is a product. Let's call it as V2. V2 V. Yes. Okay. Now since everything is added, we can go to provide the inputs. Go next. So for feed, temperature is at 100 degree Fahrenheit. Pressure value is 290 psi absolute. 290 psi A absolute. Yes. And in the composition, select flow rate in the unit of pound mole per hour. No, not that, on the right hand side, the composition part. So we have molar flow rate, instead of kilomole per hour, change it to pound mole per hour. Yes. Okay. So we have propylene coming at 500, second one. 500. Propane is 300, first one. And then pentane is 10. Go next. This is P2. Okay. So pump 2 increases the pressure. So it has been provided the intercolumn pump 2 has increased 25 psi pressure. So pressure increase provided as 25 psi. Only psi. Go down, go. Yeah. Okay. Then go next. Pump 1. So uh, pump 1 increases pressure by 20 psi. 20 psi. Yes. Go next. Now we have rectification column data. So the rectification column has 120 stages. Total stage number are 120. Okay. So 120 series includes condenser and reboiler also. So select the condenser as a partial vapor since we have provided only vapor. Yeah, partial vapor. Now we have been given reflux ratio of 10, 10. Maybe you plug it your laptop first. Hello. Hello, Nikhil. Yeah. Okay. Reflux ratio is 10. And then bottom to feed ratio is given as 0.6. So instead of distillate rate, select the bottom to feed ratio. In the operating specification, where you have distillate rate, change it to bottom to feed ratio, and that is 0.6. Okay, go next. So stream, now it is said that V1 is entering at 120 stage, enters below 120 stage. So you can select on stage number 120. Yes, on stage 120. Go next. Condenser pressure is given as 275 psi absolute. Yes, and with a pressure drop of 5 psi. So condenser pressure drop is also given. So select condenser pressure drop as 5 psi. 5. Hello. Yeah. Can you hear me?
Understand?
Ha. Yeah. Ha. So
Understand?
pressure drop is 5. 5 psi.
5 psi.
Ha. Okay. And then stage pressure drop is given as 0.1. Stage pressure drop as 0.1 psi. Okay. Go next. Okay. So for this is stripping column, right? So for stripping column, total stages are 100. Okay. Then this stripping column is without any condenser. So condenser is none. Okay. Reboiler duty is given. So so in the operating specification, select the reboiler duty. Reboiler is fine. In the operating specification, select reboiler duty. Yes, that is 1 into 10 to the power 7.
1 into
1 E7.
You said
7,
electricity
7,
power?
7. Yes. And these units are in BTU per hour. BTU will be up. Go up. Go up top on the top. See, first option is BTU per hour. Yes. Okay. Go next. Here the feed is entering at, the pump out is entering at above 70 stage, 70. P out is on 70, above stage 70. Okay. The stream R1 is entering above stage 1. 1. Okay. Go next. The top stage pressure of stripper is 280 psi absolute. 280. Absolute. Okay. And with a stage pressure drop of 0.5. So stage pressure drop is given as 0.5. No, not the condenser. Stage pressure drop 0.5 psi. Yeah, I think all the inputs are complete. Run the simulation. Vijay Kumar, you have some doubt?
Sir.
Yes or no?
No, sir.
No, okay. So you're just saying hi. Okay, hi.
Sir, I have forgotten my application number and password, sir.
In that case, can you contact somebody from Swayam or NPTEL portal? Because I'm not related to any of that process. I'm just here to do this live interaction session, teach you about Aspen Plus. That's it. The other administration
Sir,
part. Yes.
Sir, how can I contact?
So you might have some helpline number in the Swayam portal, right? Let me see.
Yes, sir.
It's running. Okay. Terms of use support. See, on the Swayam portal you can see Swayam helpline or support. So maybe go there and ask them what's the issue, how you can resolve it. Okay. Yeah, I think it will take some time.
Application ID I will forget. Password is necessary to write the exam, sir.
Password is necessary to write the. See, okay. I'm not sure at all because I haven't given any NPTEL exam. I haven't taken any NPTEL course, so I don't know. And as I said, I'm not a part of this administration process. So you can ask somebody. They will help you out. Okay.
Sir, will you please give me the contact numbers?
I don't have any contact number. See, let me share my screen. Nikhil, once the simulation is complete, let me know. Okay, so
Okay, sir. Thank you.
it's done. Just few minutes, Vijay. I will show you. Can you show the results?
Okay.
It's showing an error. Display run status. Okay. Click OK. Yeah. So the following unit operation blocks. Can you click on run status in the result summary? Yeah. The following unit operations blocks were completed with the error pump P2. The following balance. Can you click on the rectification column RECT? Warning: feed pressure is lower than the stage pressure. Okay. And then what is the error in stripping column? Can you go down? On the left hand side panel, look at the result of stripping column. On your left side, the left hand side panel where you have multiple options. Scroll down. On the left, here. Scroll down, go down. Here also select on the results. Go to the status part. Block strip is not in mass balance. Mass inlet flow is 0.1 into 10 to the power 2. Mass outlet is 0.1 into 10 to the power 2. It is showing some error, relative difference. Okay. I think then it might be some issue with the data provided. So it is saying the stripping column data, it's saying that the feed is coming at the lower pressure compared to the column. So in that case we have to change the pressure of the input feed. Okay, so let's say this was giving an error for rectification column. Click on the rect, go to the stream summary of rectification column. No, not this one. Go down. Rectification. RECT that we have given. Here. Yes. Go to the stream summary of this block. Go down. Still go down. Yes. You can see the stream summary where. Okay. This is also fine. Let it be. So we had V1 coming inside. So can you look at the pressure of V1 is 19.3 bar. Okay, and which is entering at the bottom. Now in the rectification column, click on the profile.
So it is going to rectify.
Yes, so it's coming at 19 bar. V1 is coming at 90 bar. Click on the profiles. Above stream results, you will find the profile option. Yeah. Now, so go down. So stream is entering at stage number 120. So this is the last stage, and pressure value is, scroll down completely. Go to stage number 120. Okay, so bottom pressure is around 20.118, which is slightly higher than the one stage pressure on the stage 120. Because of that we are getting this error. Okay, so this can be changed by modifying the pressure of stripping unit. So here stripping unit was operating at 280 psi. So instead of that we can increase its pressure to, let's say, 300 psi. Then this error should go away. Can you go to the stripping column input? Input of stripping column. Go down. Setup. Now instead of 280, select 300 psi pressure value. Yes, select 300 pressure value. 300. Reset the simulation and run it once more. Processing input. Okay, let me know once the inputs are done. So to answer your question, Vijay Kumar, yes. So Vijay Kumar, you can see my screen, right? You can pin it. So in the Swayam portal here, If you will go to bottom, you see some Swayam helpline, right? Let's say you want this NPTEL part. You have this support at the rate NPTEL IIT Madras.at.in, and these are the phone number also. Okay, so that is available on the website also. So you can just call them or mail them, and they will. So generally they provide a better feedback, so they will answer you. Since I don't know anything about this, so I am not able to assist you here.
Okay, sir. Thank you, sir.
Yeah. Let's see, Prof. Yeah, it will take some time. I guess the problem statement has some missing, the not correct data, not missing data, but data are not correct. Because of that, we got this error. But you are understanding what is happening here, right? That feed on the stage 120, it's entering with the 19 point some bar pressure, while stage is operating at 20 bar pressure. So clearly there is a difference. So because of that, you are getting this error that feed is below the pressure of the column. Okay, so we can rectify it by changing the pressure of the preliminary, not the preliminary, the prior column to that, and that should give you a better answer. Has it completed? No. Anyway, let me close this. I don't want it. Calculating. It's still giving an error. What are the errors? Check the status. The block P2 is not in mass balance. Okay, and then apart from B2, what other error we have? I think stripping column has some error now. Can you go to the result of stripping column? Go down, see the results. No, result part. Can you click on the result part? See the status. Red flag not converge in 25 outside loop iteration. The following stage is dried up, vapor or liquid flow approach is 0. The following message was issued. Block strip is not in mass balance. Okay, I think there are some data issue here. Can you go to the profiles? So each stage we have liquid vapor from mole, liquid feed, heat duty, liquid. We have liquid flow, vapor flow. Can you scroll it down? Can I just see the scroll down? I just want to see the overall values of liquid and vapor flow. So it said that following some specification were dried up. So yeah, scroll down completely. No, there is a flow rate. So why it's giving this error? Can you again look into the result part? What was the exact error? Yeah, result parts. Check on status. Last stage, stage 100, dried up, vapor or liquid flow approach is 0. Go again to the profile and see the stage number 100. go again to the profiles. हाँ, go to stage number 100 bottom. No, not for this. हाँ, go down. हाँ, on stage number 100 you have liquid flow, vapor flow. Then why it's showing that column has dried up? Okay. I have to check this. I think the given data might have some issue in this problem. Okay. Else this is kind of also becomes a problem for troubleshooting, where with the given initial guess that you have started, you are getting errors in your simulation. Then how to modify it, how to rectify it. So as we saw that the rectification column was operating at higher pressure compared to the feed which was entering it. So for that we increase the stripping column pressure, and then that error gone down. Okay, so that way by changing some other parameter also we should get the steady state. Yes, yeah, go ahead. Nikhil. Yes, yes, speak out.
Okay.
Sorry, your voice is breaking.
Screen stop कर देते.
Yeah, okay, yeah.
Okay, sir.
Yeah, you stop it. Stop the screen sharing. So I have to look into this problem. Again, I didn't had much time to run this simulation prior to the today's lecture. Maybe some sort of a data modification might be needed, or we are making some error. So again, saying this and the first example also, where the F factor, the flooding factor, where we have to exactly provide it, I will update you guys on that. Okay, that was regarding the simulation examples for today's class. Then I had planned this quiz. Let me share my screen. But since we are almost out of time, so what I will do, I will just show you what I had uh, planned for today's quiz. Maybe you can look into this problem later and try to answer it on your own. Okay, so I think last time some students was asking me to make this quiz which I was making earlier. So I have made I think multiple questions, and some of the questions, so there was one other student, right? Atish was asking that for the exam what questions will be asked. So you won't be asked to do any simulations. Either it might be this sort of a question where theoretical part is given, like what is the purpose of absorber in the absorption process. Okay, so that is to remove the gases, where your gases will be dissolved in your absorber. It is generally a liquid. So these are basic theoretical questions. Some questions related to Aspen Plus, like in Aspen Plus, which unit operation is typically used to model a catalytic reactor. So we have seen R plug we have used with a catalyst that way. So these are the basic questions, and some other questions which might come are related to the simulation aspect. But again, you don't have to do a simulation. You might be provided the snippet of any simulation, and from that you have to interpret what are the answers. So as you can see here, let's just look into this example first. Okay,
क्यूएस कहाँ है? लिखो कैसे?
yes, sorry.
मतलब ये क्यूएस तो आपके पास है.
हाँ,
हमारे पास तो विजिबल नहीं है.
Isn't it shared? My screen is shared, right?
मीन्स ये क्वेश्चन आपने फास्टली दिखाया है, रीड भी नहीं कर पाए.
Arey, because I don't have a time, so that's what I'm saying, that I'm just giving you an overview. I will share this PDF like, sorry.
पूरे टोटल कितने क्वेश्चन इन्वॉल्व है?
I think I have made many questions, so like somewhere around 55 or something.
हमने सर एक भी नहीं करे.
55. Sorry, again. See, let me first stop the presentation.
Sir, would you share this presentation with us?
Yeah, it has been already
Possible?
shared. I think. Okay, let me put it this way. I think you guys are not following this interaction session properly. So if you will see in the course profile, I have been sharing this all presentations, even for me and both Rajdeep. So if you will go into your course, in the bottom you see the problem solving session, right? Problem solving session recordings. You click on that. If you will click it, it will take you to this Google Drive. Google Sheet. You can find all the video links for all the week's lecture and the presentation also. So for me, I have uploaded this presentation on the Google Drive, and this links is already shared. Okay, so from week 1 to 11, and this week 13 quiz also I will share, and this problem statement also I will update. Okay.
So, sir, in examination, so this type of problem is also it only comes. There is no simulation.
No simulation part.
Only theoretical questions.
So theoretical question, and like this question, you might be provided some simulation snippet, and then you have to interpret the answers based on the snippet. So this is the basic example. Okay, now let's say you have been provided this 3 snippets, and based on that this questions have been asked. Okay, so the missing component indicated by
like
sorry.
Yes, sir. Like we have in week 12 assignment, that PI wala questions.
Yeah, so like all the assignments you have done so far. So part A contains theoretical question or some sort of a snippet, and the questions has been asked on based on that. Okay, so that way.
Right, sir. Thank you.
Yeah, so what I will do, I will upload this on the drive. Again, you have an access to it. I have been repeating it multiple times. Please look out through it. I had planned it to do some simulation and then do this quiz, but I think I don't have any time, and I would like to stop it here. So this PDF will be shared. You guys can access it and practice on your own. Okay, and be prepared for the exam. It won't be, I don't think so it will be that difficult if you had followed all the sir's lectures, done the simulations, tried out simulation in the Aspen Plus, try to understand all the things. Okay. Now before closing today's session, do any of you have any further doubt, or should I stop the recording and stop the session? Okay. If no, then I'm stopping the recording.